All right, hey there, Renaissance students. Today we're going to be talking about the moon. So let's get on to it. So the moon is formed shortly after the Earth was formed as an object the size of Mars collided with Earth. We call this object Theia. The resulting debris that got scattered out into the solar system eventually coalesced into what we now call the moon. So some evidence for this theory. One is the tilt of the Earth. Remember, our Earth is tilted at 23.5 degrees. And this tilt is evidence that at some point during its formation, it probably got hit by something that caused it to tilt off of its axis. It's not perpendicular to the ecliptic as it goes around the sun. And the moon is made out of low density material, lower density than we would expect. If it was formed at the exact same time as the Earth, it would have the same approximate density, the same types of layers that the Earth does. But we've noticed that the layers are a little bit less dense, which means that as Theia came by and ran into the Earth, the lower density materials that are closer to the surface sprayed out into the solar system, and that's what would eventually form our moon. So the phases of the moon. So this is probably the thing that we see about the moon most, right? It's the most noticeable. It's caused by the revolution of the moon around the Earth. So you can see this diagram right here. We got the moon going around the Earth, and that's going to change how much light we see reflected off of the moon. So here it is in a little bit bigger. So you can see over here, when the moon is on the opposite side of the Earth from the sun, we're going to get our full moon because that entire face is going to be reflecting light back at us. On the opposite side of that, our new moon, we're not going to see anything. The moon's actually going to be out during the daytime and not going to be reflecting any light back at us. Now, in between, that changes throughout the month. Now, this takes about 29.5 days to occur. So we're going to see how the amount of light is going to change as the moon is moving around the Earth. So as I said, it takes 29.5 days for a complete cycle, but it only actually takes the moon 27.3 days to go around the Earth. Now, the reason for this kind of discrepancy is because the moon actually has to kind of catch up in its cycle because the Earth is also moving around the sun. So the moon is kind of catching up as it moves through the solar system. So there you go, because the Earth is also in motion. So here we go, 29.5 days. We can see the amount of sunlight that is reflecting off of the moon is changing. The amount that we can see is going to be changing. And you can see everything always kind of moves from the right. So the light grows from the right, and then the darkness also grows from the right light. So just like the Earth, the moon is both rotating and revolving around the Earth. It rotates at the same rate that it revolves. This is why we always see the same face of the moon for every single full moon. So as it's moving around the Earth, it's actually also rotating at that same exact rate. We always kind of see that same look on the moon. We've measured this by looking at the different craters that are on the face of the moon, and we can see that they are the same no matter which full moon we're looking at, no matter what month it is. So the moon is always kind of moving at that same exact rate. So look familiar? So we can see this crater right here. If you go out on a nice full moon, you might even be able to see that from Earth. And you're always going to see that every single full moon because the moon is always kind of facing us in the same way. All right, so let's talk about eclipses. So we got two different types, lunar eclipses and solar eclipses. So lunar eclipses are going to occur during the full moon phase, and this is when Earth is blocking light from the sun. The Earth is getting in between the moon and the sun. And solar eclipses. Solar eclipses occur in the new moon phase. This is when the moon is blocking light from the sun. So the moon is getting in between the sun and the Earth. So here you can see an example of our lunar eclipse. We've got our Earth right here, and it's blocking the light coming from the sun. Now, it's casting a shadow. A shadow has two parts. We've got the umbra, which is the dark middle, and then we've got the penumbra, which is the not quite so dark part of our shadow. Every single shadow has these two parts. So the umbra, fully shaded inner area of the shadow, and the penumbra, less shaded outer area of the shadow. So our solar eclipse. Now, solar eclipses have much smaller shadows than lunar eclipses because the moon is what's doing the blocking in a solar eclipse. The moon is getting in between the sun and the earth and casting a small shadow onto the earth. So why don't we have an eclipse every single new and moon and full moon? You'd expect, right? If the moon is going to be blocking, it's going to be blocking every single month. Well, because the moon's orbit is tilted at 5 degrees. It doesn't go along with the ecliptic. So you see here, so there's certain times or like eclipse seasons that we have where the sun, the moon, and the earth are all in the right spot that are going to be favorable for having eclipses. So right over on this side, we see this is unfavorable because look at our new moon. Our new moon is too high, it's above the earth, and our full moon is going to be too low, it's going to be below the earth. So we're not going to get an eclipse during that time. Over here on the far side, you're going to see the full moon and the new moon are both right in those exact spots that they need to be in order to have an eclipse. So you're going to see that eclipses kind of occur in seasons. They kind of occur. If you have a solar eclipse, you're going to have a lunar eclipse during the next full moon. If you have, a solar eclipse during your full moon or new moon. So why are eclipses considered rarer than lunar eclipses? So the area they are viewable is much smaller. Remember, the moon is going to cast a much smaller shadow onto the earth when it's blocking the sun compared to the earth casting a much larger shadow onto the moon. All right. So tides. Tides are the rising and falling of ocean water due to the gravitational pull of the moon and the sun. So right here, I've got a video that's been playing. We've got a high tide coming in. This is the Hopewell Rocks. This has the largest tidal differences on Earth. This is in the Bay of Fundy in Canada. And you can see the water is rising and now it's starting to fall. All right, so why are tides occurring? So the moon is orbiting around the Earth. And as we know, anything with mass is going to exert gravity, right? Even though the Earth's gravity is stronger, and that's why the moon is orbiting us and not the other way around, the moon is still kind of pulling on us as well. You got to think of it like two people pulling on a rope. There's some going both ways. So because of this, it's going to form kind of a bulge in our Earth's oceans. And as we rotate in and out of that bulge, we experience high and low tides. You can see this person right here rotating around on Earth. As it rotates into the high tide, the water level is going to rise. And as it rotates into a low tide, the water level is going to decrease. Now, tides are not the same way throughout the entire year. The face of the moon actually has a big important role to play in how much we're going to see tides. And we have two types of tides. We got spring tides and neap tides. So neap tides are going to occur during the quarter moon phases, when the moon and the sun and the earth are not all aligned with each other, right? They're going to have a harder time kind of pulling on that water. So you're going to have small differences in our tidal heights during those times. There's going to be little highs and little lows. It's not going to change a whole lot. Whereas spring tides, this is when we're going to have full and new moons. If you think about the alignment of the earth, moon, and the sun, they're all going to be on the line together. And they're all going to be pulling. So you're going to have huge differences in your tides. You're going to have big high tides and low tides. All right, so that does it for all of our Earth's motions and seasons and the moon. On to the next unit.